So Paul is going to speak about language model agents may fail to act on their own risk knowledge. Paul is from the University of Toronto, and I wish to have a nice discussion session afterwards as well. So I'm really looking forward to having more chats about your work.
Yeah, thanks for the introduction. And I guess I could get started. Yeah. So we hear a lot about organizations adopting AI, but most still hesitate to deploy LM agents in real workflows. And that hesitation comes from the shift from generating text to taking real actions like sending emails, updating systems, and making purchases, where mistakes have real consequences. And even well-aligned models can misinterpret instructions, leading to unintended actions. And a small mistake like messaging the wrong person or overwriting a file can quickly become a financial or compliance issue. So what matters most is identifying when and why agents take unsafe actions. And one interesting phenomenon we observe from LLM agents is that uh, language models fail to recognize risky scenarios when acting as agents. So I included here an example of interacting with ChatGPT, where when the user asks the agent to clean up some files in my laptop, the agent gives a very risky command to remove like all files in the current directory. And so the ChatGPT agent executed a very dangerous command and issues a warning post-execution. But when we actually prompt the underlying language model and ask it whether it's executing something like sudo remove -rf is dangerous, then the language model will answer yes. So there seems to be like a disconnect between the language model's risk awareness and its safe execution capabilities. And in our work, we want to investigate whether this phenomenon is general across all language models, or is this just some like a case. So in our work, our core contributions can be, so we introduce a systematic evaluation framework that isolates three progressive dimensions for language model agent safety. We decompose it into the language model's risk knowledge, risk recognition, and safe execution. And our evaluation reveals persistent gaps between the agent's awareness of risk and their actual safe execution capability. And these performance gaps exist even across different model scales and capabilities. And finally, we propose a risk mitigation strategy that leverages these observed gaps to significantly improve the agent's safe execution. And in our work, we use risky agent trajectories generated by tool email. So, so from a particular execution trajectory, we generate three test cases. So for the first one, we call the knowledge test. And for this one, we take the full execution trajectory and feed it to a abstractor module, which summarizes the trajectory into potential risky actions and also scenario descriptions. And this formulates the knowledge test into a standard QA setting. And we also construct the identification test where we take the full execution trajectory and pass it to the language model and prompt it to identify whether risk exists in the execution trajectory. So this investigate the language model's risk recognition capability. And finally, we take the execution test. For this one, we truncate the risky execution trajectory before the first risky action. So we obtain a partial trajectory which will contain only safe actions. And then we prompt the language model agent to continue execution from the partial trajectory. And this tests whether the agent can operate safely during actual executions. And our results indicated there's knowledge identification gap and also a identification execution gaps, where all language models achieve near perfect performance on the knowledge test, but fail at increasing high ratios on identification and execution test. So this ties back to the interesting phenomenon that we observed earlier, and we showed that the disconnect between the language models' safe risk awareness and safe execution is in fact a general issue. And we also perform correlation tests with whether the gaps correlate with model capabilities. And here we show the correlation between the two gaps with instruction following score. And we see that there's no real correlation between the model capability and the two gaps that we identified. So this means that simply scaling model capabilities may not close the gaps. And so we want to use the observed gaps to propose uh, a risk verifier to mitigate the two gaps. And for this one, we propose a risk verifier which identifies risks and issues critiques at each agent to-call step. And we also introduce an abstractor which generates abstract scenario descriptions from the agent's current partial trajectory, which improves the context for the verifier to issue critiques. So at each agent to-call step, after the agent proposes a new action, we first feed it to the abstractor, which generates a high-level abstraction or like a scenario description for the verifier. And the verifier will generate risk critiques for the agent, which in turn will help the agent proposes a new action that hopefully will be more risk prone. So here we ablated the performance with or without the abstractor, and we find that the abstractor helps gives better context for the verifier. So here I included an example where the user asks to send a trade history to a email found in a text file. And on the left side, with only using the verifier takes context of the entire partial trajectory, and it can give identify irrelevant like date range as a potential risk. However, with the abstractor helps abstract like the scenario from the partial trajectory, which helps the risk verifier zoom in on the correct risk associated with missing user confirmation. And here we compare the agent's pass rate on execution test. We'll compare it with the vanilla agent, agent with safety prompting, and the agent with our proposed verifier with the abstractor framework. And we find that using the verifier with abstractor can significantly increase the agent's pass rate on execution tests, so increasing the agent's ability to generate risk-free actions. And we find that the improvement is also present in reasoning models like DeepSeek R1. So this shows that these capabilities can lead to like a general improvement with different base model capabilities. And here we also verified the safety and helpfulness trade-off with different baseline methods. So we found that the risk verifier with the abstractor led to substantial improvement in safety score while also maintaining the helpfulness. And we also experimented with ablating using different number of iterations for the critique. So we found that with single critique, this can already yield significant gains for the safety and helpfulness. So for our main takeaways, so in our work, we proposed a evaluation framework that measures two gaps for the agent risk awareness, the knowledge identification gap and the identification execution gap. And we also show that simply scaling model capabilities doesn't close the gaps. And we show that using our proposed risk verifier, which is abstractor, which converts the trajectories into high-level summaries, helps improve the agent safety verification and help bridge uh, the execution gap to generate safer agent actions. And yeah, thank you. And that concludes my presentation.
Thanks a
Uh,
lot for the presentation. Did you want to say a few final words? I thought I cut it off.
I think I'm good.
Okay, so thanks a lot for the presentation again. The floor is open for any questions. You can also post questions on Slack, but you can also use the Q&A tool here. So please feel free to step forward and say anything. Any questions? I have a lot of questions, by the way.
Okay.
So maybe I can get started with some of the questions. So super interesting talk. Um, I like the fact that you're kind of systematically separating the knowledge, identification, and execution. I think these are really nice framework that kind of works for more general situations as well. For example, we are working on the privacy and um, as far as I know, on the privacy domain, there's also this contextual privacy, where you also just ask the model whether you're going to expose certain information to certain tools. And then there's another kind of benchmark where the model is asked to execute certain actions, and we see whether the model is actually exposing the information to the external tools. And
Mhm.
certainly there are quite some differences in the model behavior. And there's no guarantee that the model safe on this probing kind of benchmark is also going to be safe on the actual execution. Um, do you think this is kind of a general phenomenon that kind of goes beyond safety scenario as well? Like the model knows something, but doesn't have sort of the capability to apply this to new situations, and maybe it lacks the ability to take actions eventually.
Yeah, yeah. So going back to like the motivating example here, like we think it's very interesting because like for example in the context of like agent safety executions, like safety can be like manifested in like different contexts. And we found that especially that under the agentic setup where the language model is prompted to act as an agent, it fails to recognize a lot of the risks. And but if you just ask it, like for example, like when we use the knowledge test and ask whether executing something risky is actually risky, then the model will answer like yes. So um, we think this could be attributed to like when doing safety training for the base language model, then a lot of the training is actually done under this like conversational QA setting instead of the agentic setting. And this actually lead to like the gap that we see, like the knowledge identification and identification execution gaps. And so tying it to something more general is so there's this a generative validator gap that is like the more general manifestation of what we can observe here. So essentially, when we ask the model to generate something versus asking the model to verify something that's been generated, the model is better at verification than like actually generating it. So we think that there's like inherently harder task of generation that is making the risk at like the to fail at recognizing risky scenarios. Uh, but we but we also but I think that we can also utilize the like the for example here we can utilize the language model's risk knowledge to help it improve its safe execution capabilities and So that is essentially the motivation with our risk verifier as well. So we are essentially decomposing the task of safe agent execution into the two-step task of with the abstractor first generating an abstraction and then using the verifier, essentially using the model's knowledge and identification capabilities to help with its execution capabilities. Uh,
Mm. Yeah, thanks a lot for the connections here, clarifying the connections. Watching this, I was wondering if this is how this compares against general React framework. Can we think of this as a special case of React, or
uh, Yeah, actually, in fact, we kind of built the abstracted and verified on top of the React framework. So in our evaluations, we so the here like the vanilla agent is essentially the React agent, and for safety prompt, we just inject like a list of safety constitutions into the React agent's prompt. And with verifier with abstractor, we included these two additional steps essentially at each step, a tool call step of the React agent.
interesting? Um, I would find it also more attractive if we don't actually have to go through these additional prompting and additional agent exchanges. But if a single model can already do all these safe execution in the first place, that would be great. Do you think there's a way to kind of make the model do safe execution in the first place, especially because the model already contains all the knowledge, right? So if there's a way to kind of convince the model to make actions based on their knowledge, which is kind of seems like a missing link somehow, that they even if they know something, they don't really feel the need to act on their knowledge. So probably the missing link is just some general instruction that, okay, if you know something, you need to probably act on this. Um, is that kind of training, does that kind of training make sense? And is that going
Yeah,
to help the model behave better?
yeah. So yeah, I think that so the idea so I can like kind of summarize it. Essentially, like what I think is that so from the like the performance gap between the knowledge test and execution test, it's like apparent that the model already contains a lot of the like the knowledge and information it needs to generate like safe agent actions. Uh, but probably with how like base models are trained or like how they're aligned with safety, there is still this missing link or gap between like the risk agent's risk knowledge in QA settings and in agentic settings. So we think that bridging this gap with either of what we're doing here with the verifier or with additional training could definitely help. And what we are doing here with the verifier just shows that the agent is in fact capable of recognizing a lot of the risks. It's just that under this like the agentic scenario, the setting with the React agent, um, then a lot of the saved knowledge is essentially being overlooked. Uh, yeah.
Hmm. Thanks a lot. In the meantime, there was one question from the Zoom QA. So the question is, could your mitigation technique be extended to multi-agent communication to avoid one agent to send risky information to another one?
Yeah, I think there's definitely a lot more exploration that can be done here with different like agent setups like multi-agent or like agent debates and such. But the most underlying thing that we want to illustrate here is with the gap between the agent's knowledge and execution. So there could be a lot of ways to help bridge this gap, and we use the I think like the simplest setup with just using the additional verifier module. And the verify module essentially um, serves to bridge the gap between the agent's identification and the agent execution. And and we also use the abstractor, which bridge this gap between the agent's knowledge and identification. Uh, so uh, so yes, we could definitely try with like for example multi-agents, but the underlying motivation for building multi-agent would still be motivated by these three gaps, two gaps, sorry, with the three capabilities. So ways to think about building multi-agents to improve safety would be to how to use multi-agent to utilize the inherent safety knowledge with the base language model, and how do you essentially pass that knowledge into when the agent is executing actions. I hope that makes sense.
Mhm. Yeah, so if you have any follow-up question, please feel free to follow up on that. In the meantime, I also another question that came to my mind was um, so you also mentioned about the potential benefit of having specialized training data for uh, making the model act on their safety criterion or safety knowledge. Um, there's a lot of training paradigms for making the models safer in terms of their like increasing their knowledge through the Q&A and conversation. What do you think is the factor that prevents people from creating a data set for making like data set for training the models to be safe in their execution?
Uh, so you mean constructing a data set, preventing people from constructing a data set that helps
Mm,
the agent safe execution?
yeah, because I feel like I haven't seen a lot of work on kind of or any work, although I haven't been following up on this domain so much. But I haven't seen any data set for training a model to be executing in a safe way.
Yeah, I guess yeah, because it is sort of intricate because current base LMs are already pretty well trained in like helping with like the user task, and I can think of one like particular like a challenge is how do you balance the safety helpfulness trade-off, like because for example in creating such a data set there's inevitably you're going to have the safety helpfulness trade-off, like if for example if a lot of the examples in your data set just comes down to the agent refusing to do something because its actions may be too risky, then like the agent training with such a data would just be like very safe, but it won't be very helpful to the user task. And this is um, and this is something that is also like very hard to this how do you say instill into like if you want to construct such a data set. Like essentially I can think of related to like mathematical math problems like um, you so essentially you want the agent to be safe, but also not safe as to you'll just not do anything. It will not be very helpful.
Yeah.
So what will end up to have like a good quality data set is that you need to have like essentially it would be very difficult to construct such a data set that can have like a good mix of balance between safety and also helpfulness. I'm just from my intuition is that my uh, yeah, essentially like helpfulness will be difficult to be like instilled into such a data set, I think.
Mhm. Thanks a lot for your insight. There's another maybe final question from Martin again. Another unrelated question. Thanks, it does make sense. It does make sense. Great presentation. Another unrelated question. Could reasoning help the model to better reflect on its action to align better its decision to its knowledge?
Yeah. So that is actually something that we test as well with using DeepSeek R1, the reasoning model, as one of our baselines. Is that interestingly, we find that reasoning does not really affect like the basic trend that we see here with the knowledge identification and identification execution gaps. So here, this is more apparent here. So here we see that the DeepSeek-1 actually displays the exact same trend as all the other models. So it has a lot of a great deal of knowledge in different recognizing risks, but at identification and execution, it still lacks. It behaves essentially the same as other models. And we think that this just means this safe execution capability at this moment is like orthogonal to the reasoning capabilities, or at least when training the models, uh, the the reasoning was not really tied to safety. So maybe there's not a lot of safety related reasoning training when training like DeepSeek-R1. So we think that that is a gap that current uh, even recent models have with relating to like safety executions in agentic settings.
Okay, thank you so much. If Matang has any follow-up question, please you can continue on Slack again. Thank you. So in the meantime, the second speaker, EunJeong, has joined. Hi, good to see you.
Hi. Let me share my screen.
Yeah, so one thing, it's supposed to be like the two speakers kind of moderating each other actually. So, but maybe there was a bit of confusion actually. It's the first series of the whole series, so it's a little disorganized, I know, and the instruction is super long, so maybe it's not so clear. Um, but maybe for the second speaker, can we kind of resume this and um, Paul, if you wish to kind of try to moderate the second session, that would be great. Otherwise, I can also take over for the second part.
Uh, yeah, actually, not not really sure how to moderate this session.
Yeah, no problem. Then I can take over for this time. I'll try to make this clear in the next instructions. Yeah, I sent a super long email with all the instructions. So,
Oh,
okay. So for the second talk, I think you shared the screen before, so I see that the screen sharing is working. You can probably continue with the screen sharing.
Okay.
Thank you so much. Um, in the meantime, I need to bring up the information. Okay. So the second speaker, EunJeong Hwang, is from the University of British Columbia. And EunJeong will talk about infusing theory of mind into socially intelligent LLM agents. Sounds super interesting. I'm looking forward to your talk.
Yeah, thanks for inviting me to this presentation. In today's presentation, I'm going to talk about my paper as Sungjun introduced, Infusing Theory of Mind into Socially Intelligent LLM Agent, which was out as an archive preprint a few months ago. So let me first explain what exactly is the theory of mind and why is theory of mind important. So theory of mind is an ability, cognitive ability to understand mental states of the other people. So it includes beliefs, desires, intentions, emotions, or knowledge, and so on. It includes a diverse dimension of the mental states. And it also has multiple orders of these mental states. So, for example, zero order is refers to the self-belief, the belief about themselves. And the first order means the belief about the others, which means I think the other person is mad at me based on this context. And second order belief is like more recursive. I believe that the other person believes that about person C, something like a very recursive structure. So why is theory of mind important? Because LLMs are increasingly used as social partners in real world applications like mental health support, personalized guidance, or decision making process. And this the success in social interactions with human depends not only on expressing our own beliefs, but also on understanding our partners. So on the right side figure is one example of social scenario where two friends are camping in the wilderness and the temperature drops significantly at night, and these two agents have the different goals from each other. Agent one's goals is to share the only blanket available, and agent two's goal is to keep the blanket for yourself as you're also very cold. So if these two agents have a good sense of theory of mind reasoning ability, the agent one will be able to understand that agent two wanna keep the blanket for themselves, and agent two will understand that agent one wanna share the blanket available. So at the end of the conversation, if they have a good social reasoning ability, they would be able to reach to the reasonable solution where these two agents rotate the blanket over the night multiple times. So let me briefly explain the current status of theory of mind in LLM agent. The extent to which LLMs are already possessed theory of mind is debatable. Some papers actually argue that LLMs have theory of mind, but lots of other analysis paper actually argue that theory of mind reasoning ability in LLMs are very brittle. And I actually think this is one of the reasons that why the theory of mind reasoning hasn't been developed in LLMs properly, because the past works on theory of mind for LLMs evaluate this ability on question answering setups. So this is surprisingly like this example that I show in the presentation is surprisingly one example that is included in the theory of mind bench, where a story is Mike wins the championship in a piano solo competition and receives praise from his brother. And the question is, what emotion does Mike likely show? And this is so obvious, but and it's not even related to the theory of mind. Like it's lots of like this theory of mind are like based on this multiple QA setup. Like of course I picked like a little bit bad example, but these theory of mind questions actually can be solvable using like common sense that doesn't necessarily require LLMs to be to infer the other person's belief. And also another problem is LLMs are acting as a third person perspective. It's not really like interacting with another person, like they just need to answer the question. So we don't know if they are answering based on the pre-trained knowledge or not. And another line of research focus on interactive social environments. And existing research in interactive social environments focus on generating better utterances. Like typically they use DPO or like some preference optimization technique to pick the better utterances based on the reward. So in our work, we want to answer this question. So could giving LLMs a theory of mind make them better collaborators, negotiators, or generally better social reasoners? So we propose a method which is agent TOMA. TOMA stands for the theory of mind agent. And this TOMA is trained based on a framework that integrates theory of mind driven mental states and utterance prediction using conversation simulation. So in the first step, we see the scenarios and agent, where the scenarios are like these social scenarios. Two friends are camping in the wilderness and temperature drops significantly at night. And these agents two have different goals and they continue the conversation. And let's say they had some conversation for like two turns, and then the current turn is for agent one, and agent one need to speak something. And so for that, the agent one becomes the target agent, and we sample to create the data set. We to teach the theory of mind reasoning for the LLM agent. We sample K mental states of this agent one. which include beliefs, desires, intentions, emotions, and knowledge. And for each mental state, we sample J utterances. So, and then for each pair of like mental states and utterance, we simulate the dialogues up to certain points, like four turns in the future. And then we calculate the goal achievement score of this agent uh, based on the simulated dialogue. And then once we calculate the goal achievement score, we select the mental state and utterance pair where the goal achievement is higher than 9, and then we collect all these mental states and train the model based on that. We use simple like cross entropy laws where like this one is previous history or other existing information, including scenario, agent, personal information, and social goals. And we generate the mental states. And then once we have the with this mental state, we also train the model to generate the utterance paired with this mental state. Our experiment focused on Zootopia dataset, which is an interactive social evaluation dataset. So in Zootopia, each instance includes scenario, agent, private information, and social goals. And it has all set and hard subset. Hard subset includes more scenarios where the agent social goals are conflicting each other, but or set actually includes lots of like cooperative scenarios as well as like conflicting scenarios between two agents. And we use for additional baselines along with Toma. Base is just vanilla LLM for conversational agent. And base plus MS is basically we are adding the mental state prompting before generating the utterance in the conversation. And SFT plus utter is we fine tune these LLMs on utterances only. So basically in this figure, we remove this, you can think of it as we remove this step 2 and we sample utterances only and then calculate simulate the dialogue and then scores and then collect all these utterances that achieve high goal scores. And then SFT plus mental states, it's similar to the utterance model. We fine-tune the LLMs on mental states only. And SFT plus MS plus utter means we fine-tune the LLMs using mental states and utterances together. So evaluation score is calculated using LLM as a judge. We focus on our evaluation on these 3 dimensions. One is relationship, which is about whether the interactions between the agent help preserve or enhance their personal relationships. And the second one is knowledge. Knowledge is about whether the agent gained new and important information through the interaction, and goal is the extent to which the agent achieved their goals. So here are some of one of our main experimental results. We test like these 3 different models, QN 3 billion, 7 billion, and Llama 8 billion. And as you can see, the first table is on OR split and the second table is hard split. And as you can see, our Toma variant perform the best overall in all dimensions across all models. And also, if you see like the mental state conditioning models, comparison between the base and base MS and also SFT plus MS, we actually see very high substantial improvement on relationship dimension as well as goal achievement dimension. Even so, and also this SFT plus mental state model is not fine-tuned to generate better utterances, but still, like if the model knows how to produce the better mental states, then it can significantly improve like this relationship and core dimensions. And also this is another experimental result. The figure is about the goal completion scores across 5 to 20 turns on the hard split. X-axis is the turns and the Y-axis is goal scores. And it's also pretty interesting that our Toma agent can, as the iteration of the conversation goes on and on, the Toma agent actually recover the goal achievement score, and it actually improves at later turns. But if you see like base and base MS, their performance at later turns saturate very quickly. But another part is that base plus MS, which add the mental state prompting, actually recovers some performance at later turns, even though it performs worse than our Toma agent. So basically, better theory of mind reasoning ability in LLM agent can enable the long horizon adaptation. And our previous main experimental result mainly focused on the surface setup where the fine-tuned model play against the same fine-tuned model. But in this setup, we compare the asymmetric setup where the target agent is fine-tuned and the other agent is like just plain base model that has different sizes of the models. And we see the goal score of Toma agent. And the first rows, the upper side rows is like both agent average scores, and the lower part has the target agent goal scores and or dimension scores. And as we can see, Toma agent actually perform the best in almost all cases. And also, if you see the both agent average scores, Toma agent perform the best in almost all cases. So basically, what this says is that Toma target, if the model has a good ability of theory of mind, it not only improves its own goal completion or relationship score, but also they can improve their partner's goal completion and relationship scores. And we also provide some comprehensive analysis about top 7 reasons for success and failure behavior in these social scenarios. We classify this agent like success and failure strategy into like these canonical labels. And we also categorize these social scenarios into like 4 different categories where cooperation, negotiation, persuasion, and conflict scenarios. If the first upper part is the base model's top 7 reasons, and the lower part is Toma model's top 7 reasons. And as you can see in this figure, Toma model actually shows more strategic reasoning across diverse scenarios, meaning that it shows like compromising, accommodation, or solution offering compared to the base model, where it shows the rapport building, relationship building, like persistent request. So you can see that our model actually exhibit more like strategic behaviors. And if you see like top 7 reasons for failure mode, base model actually exhibits lots of passive behaviors like failed to initiate or lack of action. But in Toma model, we actually decrease those cases significantly, and we focus more on failed to persuade, ignore preferences, or information gathering failure. So Toma exhibit more active behaviors even in the failure mode. And if you see like the scenario percentage, you can see the base model focus on lot of cooperative scenarios, but Toma model actually perform better on more like complicated social scenarios where more advanced social strategies are needed, like negotiation or persuasion. And we also provide another analysis about the mental state. So figure 5 is the distribution of the mental state dimension on 3 billion model. And we can see that when Toma variants actually focus a lot more the intentions over emotions. And it also prioritizes the first order beliefs in both models. So basically, we can see that like we can see in this analysis, perhaps the understanding the intentions of the other agent is important to exhibit the strategic behavior, and also based on the this first order percentage where the theory of mind reasoning agent exhibit more first order beliefs. We This might contribute in exhibiting like more strategic social behaviors. So to recap the key takeaways of our paper, we introduced TOMA, a training framework that integrates theory of mind-driven mental state and authors prediction using the conversation simulation. And we demonstrate substantial improvement over baseline in both relationship building and goal achievement, as well as the knowledge acquisition. And we also offer the comprehensive analysis, and it shows that effectively inferring others' mental states can enable more strategic or oriented behavior, support long horizon adaptation in social conversations, and it can enhance the relationship management with other agents. Thank you.
Thank you so much for the great presentation. Super. So any question from any audience? Likewise, I have a lot of questions, so maybe to best use time, I'll just get started, and I'll wait for the others to maybe type in on Slack or on Zoom. So for me, the question is whether when you speak about theory of mind, I'm wondering if that's primarily about theory of mind against the human or against another model.
That's a good point. In our work, we refer to theory of mind of the other agent because our setup is playing against the other agent. But we are hoping that this agent performance actually also transfer to the human performance. And this requires some human study. Yeah. But yeah, we focus on agent theory of mind.
Yeah, I think both cases have their own kind of practical scenarios. So I don't think one direction is more correct than the other. But also that brings me to the question of the data set that you use. I think the data set is created by humans. Is that right? Or can you maybe explain the data set once more? The one that you used for evaluation. I'm mostly wondering about how this was created.
I think the original authors of the dataset actually aggregate all these like social reasoning benchmarks, and then they probably prompted these GPT-4 models to generate like to convert some of the social questions into like scenarios and generate like private goals. They probably use the LLM to
Hmm.
I need to double check about this, but I think they used LLM to generate all these different scenarios and private information or goals. Yeah, conversation history, as soon as we have like this agent information, goals, and scenario, we can kind of generate these conversations between these two models. So
I see. Then, yeah, to me, it's a question whether the ground truth sort of is that a question answering task, by the way?
Oh, so this task is basically we have the scenario and we have the agent private information and agent these two agents have like separate goals, and we just let the agent play each other. We just let the agent continue the conversation and then oh, oh And then at the end of the conversation, we continue until like 20 turns. And then at the end of the conversation, we give the entire conversation history to the LLM agent. And then we ask LLM judge to evaluate with the relationship knowledge and core achievement scores.
Mm-hmm.
Yeah.
I see, I see. Okay. So there's no real ground truth in this whole sequence.
Yeah, there is no real ground truth.
I see. Mm-hmm, mm-hmm.
So
Okay.
yeah, I think it's a good point. Like I think LLM as a judge is some people view it as a limitation of this approach because we don't know how much it aligns with the humans or um, we basically need to rely on the LLM judge's performance on like these dimensions. And like after and then after this work, we ran additional human study that like tried to validate this LLM as a judge outputs the reasoning and the scores for each dimension. And then after this study, we also ran like the human validation study that whether the reasoning chains from the LLM as a judge is correct or like aligns with the humans or not. And we find it's pretty aligned, like 90% of the time, with 90% of average of 90% of the annotator agreement scores. Yeah.
Mm-hmm, mm-hmm. Sounds great. There was another question in the Q&A panel. So I'm gonna read it for the YouTube audience later on as well. So from Elena, thank you, EunJeong, for the presentation. I was wondering how much theory of mind corresponds to the requirements for understanding the pragmatics of certain linguistic expressions with concrete knowledge of the word. Do you know that, at least in principle, it would be useful in this context to include multiple modalities to make agents more robust more robust in this type of task?
Of course. Yeah. I mean, of course, including like more modalities would be beneficial to make the agent perform in the real world cases. But and we are also working on another project that tries to integrate another additional modality in like visual modality into this theory of mind. Um, it's not super easy, uh, but I would say it definitely helps if we can add the additional modalities because if you think about like theory of mind in real world situations, people see people see object or persons like facial emotional expressions or gestures, and they also um, those like emotional or emotional those like facial expressions or gestures actually produce lots of uh, non-literal meanings, and that requires advanced ability of this theory of mind reasoning about whether this person is mad or whether this person is happy or annoyed, that kind of stuff. So yeah, I would think it definitely helps with pragmatics of linguistics as well as like if you integrate more like modalities, it would definitely help in advancing this theory of mind reasoning ability of LLM agent.
Thank you. I have one more question. So I was wondering, so I mentioned this human theory of mind for the model. Um, and maybe this is just a comment from my side, and I wish to understand what you think about this. So the problem that I see um, a lot of times when I speak to an LLM is that it doesn't seem to have a theory of mind for me. It doesn't seem to it doesn't do its effort to kind of understand what I have in mind. So I'm using coding agent a lot of times, and I try to instruct the model to write some code for me. And okay, nowadays they are asking me back again, like what I have in mind, and like with cursor, you're given a list of choices like, oh, one, do you want A, B, C, right? And then you can just do multiple choices. That's super great. But also, I don't really feel like, for example, I want the model to learn right away how to write an email on behalf of me. And for this, I don't think there's only one round of this exchange will kind of really tune the model to be really like me. But I think the model has to somehow come with some examples for me, and then eventually we agree on the mode of speech for or the tone and manner in the emails that they can just go ahead and speak on behalf of me. And I think part of that is actually theory of mind, that whether I'm the model trying to guess what I have in mind. I'm not sure if that's something that you'd call theory of mind as well, or
Yeah, I would definitely call that because theory of mind is basically the ability to understand others' beliefs or intentions. So basically, I believe that the model has better ability to understand what other person is trying to do than they would ask more better clarification questions, or they would perform better at ambiguous reasoning tasks. I also see another paper recently came out that they try to integrate this theory of mind into this coding agent, and then they try to understand the intents of this user better. So it's definitely a good point, and we need to kind of see how this is actually gonna help in this like the product level. Yeah.
I think this also nicely brings back to your final point that once you improve the theory of mind somehow, then the model can do some ordinary tasks better, not necessarily related to kind of interpersonal, intel-agent relations.
Yeah, I would think so. And it also relates to somewhat like human user modeling, like to deal with these ambiguous instructions and these things. So yeah, I would be excited to see more works on how to uh, like extend this theory of mind into these type of tasks. And I'll be also working on this domain. Yeah.
Perfect. Thank you so much for presenting the work. The time is up actually, so we have to close this soon. Thanks again, everyone, for joining today. And I wish you have a good day, have a good night,
Yeah,
and
thanks for the invitation. I'm
thank you.
not yeah, like this is quite early right now in Vancouver. I usually
Oh, yeah,
uh uh wake up pretty late, so I hope my presentation made sense.
it made a
Um
lot of sense. Yeah, no
yeah.
problem at all. And if there's any remaining questions or feedback, please use Slack.